This robot has a Unitree body, Sharpa hands, and late this year, anyone will be able to buy one. But the brain inside it, the simulator it trained in, and the computer behind that chest panel are all NVIDIA. And it is not alone. Boston Dynamics, Nura, Agibot, a growing list of robot companies now builds on pieces of the same stack. This is not a product launch, it is a platform play. NVIDIA does not need to win the robot race. It just needs every competitor to depend on its nervous system.
Quick honesty check before we go further. NVIDIA does not run every robot on Earth. Some companies use the whole stack, some use one layer, and some are fighting hard to avoid it. That spectrum is exactly what this video is about, because you can now see it, layer by layer, in public. Start with the machine you just saw. In late May, NVIDIA announced a reference Humanoid, a complete working robot design that research labs can buy and build on instead of engineering their own from zero. The body is a Unitree H2, nearly 6 feet tall, about 150 pounds. The hands come from a company called Sharpa, 5 fingers each with pressure-sensing fingertips, 22 joints per hand. Add it up and the robot has 75 degrees of freedom, which is robot speak for how many independent ways it can move. Labs like Stanford and ETH Zurich are first in line, and Unitree plans to ship it late this year. It is a research machine, not a warehouse worker. NVIDIA is handing universities a standard robot, the way it once handed AI labs a standard chip.
Now open it up, because the interesting part is what NVIDIA put inside. Think of the stack as 4 layers. At the bottom, the body. Motors, joints, cameras. NVIDIA does not build that. Unitree does, or Boston Dynamics, or anyone else. Above it, the brain, a model called Isaac GR00T, trained to turn what the robot sees and hears into movement. Beside it, the gym, Isaac Sim, a physics-accurate virtual world, and Isaac Lab, the training software that runs robot school inside that world. And on top, the computer that rides inside the robot, Jetson Thor, the chip that runs the brain in real time. Body, brain, gym, onboard computer. NVIDIA sells everything except the body. Why does the gym layer exist at all? Because real robots are expensive to break. You cannot crash 10,000 physical robots a day to teach them to walk. In simulation, you can. Inside Isaac Sim, thousands of copies of the same robot practice in parallel, falling, dropping things, failing millions of times at computer speed. Only the skills that survive get downloaded into the real machine. Watch the 2 arms here. One is real, one is simulated, and they move as one. That loop, simulate then transfer, is how nearly every serious robot lab now trains. And NVIDIA owns the most popular version of the loop. When training is done, the model has to live on the robot itself. No data center, no lag. That is Jetson Thor, a robot-sized supercomputer that went on general sale last year. 128 gigabytes of memory, server-class AI performance, and it sips between 40 and 130 watts, less than many gaming PCs spend on a single game. A developer kit costs about $3,500, which sounds expensive until you remember it is the entire brainstem of a machine that costs as much as a car. So who actually uses this stack? This is where the honest map gets interesting, because the answer is a spectrum, not a list of logos. At one end sits the reference robot you saw, the full package, brain to body. One step down is Boston Dynamics. The company says its next generation Atlas is being designed around Jetson Thor, and that it trains Atlas's balance and hand skills inside Isaac Lab. That is a deep dependency, stated by Boston Dynamics itself, not just by NVIDIA. Then there is Nura, the German robot maker, which publicly signed on early and shows its robots training as digital twins in NVIDIA's simulator. Keep sliding along the spectrum and you hit Figure, the most instructive case on the map. Watch these two-figure robots sort groceries they have never seen. The AI doing this is called Helix, and Figure built it in-house. The company's whole pitch is that its brain is its own. But Figure CEO also publicly praised Jetson Thor and signed on as an early adopter of the hardware. So Figure buys NVIDIA's computer while guarding its own intelligence. Beyond that, NVIDIA claims a long tail of adopters: Agibot, Agility, 1X, plus industrial giants like ABB, Fanuc, and KUKA. Worth knowing, most of those names come from NVIDIA's own press releases. Adoption of a tool is real. A takeover of their brains is not yet proven. That gap between the two is where the next few years of robotics gets decided. And at the far end of the spectrum stands Tesla. Optimus runs on Tesla's own chips, Tesla's own motors, Tesla's own training software. The company builds everything it can in-house, precisely so no supplier owns its nervous system. Except there is a twist. Reports put Tesla's cumulative spending on NVIDIA hardware in the billions, because training its driving AI still runs on NVIDIA data centers. Even the company most famous for refusing suppliers pays the toll at the training layer. If this strategy feels familiar, it should. During the AI boom, NVIDIA did not build ChatGPT or Gemini or Claude. It sold the chips and the software underneath all of them, and it became the most valuable company on Earth without ever shipping a chatbot. The software mattered as much as the chips. CUDA made leaving NVIDIA painful, so nobody left. The robot version follows the same path. Train the brain on NVIDIA data centers. Rehearse it in NVIDIA simulator. Run it on an NVIDIA computer inside the robot. Whoever wins the robot race, NVIDIA gets paid 3 times. The robot companies can see this dependency forming, which is exactly why the map looks the way it does. NVIDIA calls its tools open, and parts genuinely are. The simulator code and the GR002 models can be downloaded free, but the workflow quietly funnels you toward NVIDIA hardware at both ends. And everyone watched what happened to AI companies, whose margins now flow to their chip supplier. That is why Figure built Helix. That is why Tesla designs its own chips. One more honest caveat. Simulation training still is not magic. Skills that look flawless in a virtual gym can stumble in the messy real world, and most public demos are short, edited clips. The stack is real. Robot autonomy itself is still the hard part. Here is what to watch. In the next few months, the reference robot starts shipping to labs, and hundreds of researchers begin publishing work built on one shared body and one shared brain stack. If the next wave of robotics breakthroughs comes out of that ecosystem, the default gets very sticky very fast. The visible robot fight is Tesla versus Figure versus Unitree versus a dozen challengers from China. The deeper fight is over who powers all of them. And right now, one company is quietly wiring itself into position.